Hi friends, today let's learn about the DC earth fault locator equipment. How does it works and what exactly it gives you and how it is beneficial for you to identify the DC earth faults in a substation. So this product has all these accessories. You can see here a transmitter unit, a receiver unit, and a cable which connects to the main DC-DB system through the transmitter, goes to the main positive, negative and the ground. And then you have a power cable here which is used for to the transmitter to give power when you are using it below 110 volt DC system. This system gets energized automatically when you connect to 110 volt and above DC system. But if you are using it for a below voltage, a lower voltage than 110 volt, then you need to give an additional AC power supply to this transmitter. This is the receiver clamp, which is a standard clamp which can be used for all feeders or feeders and cables in the panels and in the field. If you have a bigger cable or bigger diameter cable, you can use this clamp which will be helpful to identify the faulty or healthiness of the feeder. This is a cable which connects to the receiver and to the standard clamp. So this is a complete accessory set which will come along with this equipment. We call it as a scope of supply. Then we'll understand about the transmitter now. So you have this transmitter. These are range selective switches and the power on switch, and you have a color coded sockets which like you have positive, negative and to the ground, and you have a AC power supply socket. You also have from the safety point of view, we have fuses, positive and negative feeder, and also fuse for the main power supply. And then if you go to the receiver unit, you have you can change to a different waveform and see what's happening in the system. This is the power on button, and then this is always a refresh button, we call it as. You can increase the gain and decrease the gain through this through this button. This receiver unit has two channels. One is a standard channel which can be used with a standard clamp, okay, along with this, and then you have another channel you can use it with a bigger clamp. So let's have a small demonstration how it works with the DC power supply. So we have created a DC system, a model. We call it as a simulator, where you can see here you have a positive bus, negative bus and a ground, and we have a balancing circuit which divides the voltage equally half. This is a 20 volt DC system, and we have created a different faults, whether positive or negative faults, and of different resistances. So you can exactly see how this equipment will give you the complete information of DC system, including the fault resistance to ground, the balancing resistance of your DC system, and also the capacitance to ground on the DC system. So now let's start. Let's do the connection. Red goes to the positive, green goes to the ground, black goes to the negative. Considering this as a 20 volt DC system, okay, we connect green first, always to the ground, then red to the positive, and then black to the negative. So you can see that we have some feeders already here, and positive feeders in red and negative feeders in black, and we have created a resistance of 47 kilo ohm fault, okay, that in a positive. So this is in positive fault, and we can see how this shows fault in positive and negative. Now we connect this clamp to the receiver unit. So the receiver is ready. Let's switch on the transmitter. The transmitter is on, and it is asking me the output power, how much it should be. So let's go with the maximum. Press OK. Then it's asked us to select yes or no. Select the switch, yes. Then just wait, and it will tell you what exactly your system details are. You can see from the receiver that it is showing that there is a positive bus bar grounded, okay, and it is measuring the voltage. You can see, as I mentioned you, the DC-DB box is of 20 volts, so it shows that 22 voltage negative and positive is grounded. Since we have created a positive fault, so it has a very low positive fault of like there is a positive to ground is 0, negative to ground is 22 volt. You can see the resistance to ground is 45k, and the balancing resistance is more than 1 mega ohm. The capacitance to ground is 4.7 microfarad. Let's see how our receiver can help you to identify which feeder is faulty and which feeder is healthy. So now we are starting our demonstration on healthy feeders first. We have to identify all the feeders healthiness. So out of these feeders, any one feeder might be faulty based on the fault to ground condition. So we switch on this receiver clamp, then just press for 2 seconds. Your receiver will be on. Now you need to connect this receiver to ground cable and see whether it is really grounded or not. So now just start the transmitting. The injection of the transmitter starts from the receiver, so you ask the transmitter to inject the signal. You can see that there is an indication on the receiver stating that the signal has already been injected. You can see the leakage current as well. The leakage current what we inject into the system. This is not the leakage current in the main DC-DB system. So now in the receiver, just refresh and check whether it is faulty or not. So it has already started sending the signal saying that there is already a ground in the system. If there is no ground, you will be having a straight line. If there is a ground, then you will get a square waveform. So now let's see which is grounded, whether it is negative or positive. So now let's connect to the positive feeder and then refresh. You can see that the positive feeder is grounded. We can see from the transmitter as well, it shows positive busbar ground. So it's very clear. Let's go to the negative, connect to the negative, then refresh. You can see that there is no fault in the negative, which means that there is no waveform. So now let's start with the feeders. Let's connect the feeders one by one and see which feeder is faulty. So we are going with the feeder 1. Always refresh when you connect to a different feeder. So the fault is in feeder 1. This is a loop connection. So we have created a fault at +4. So the signal should show in the until the feeder number 4. Sorry, until this loop 1, 2, 3, 4. So if I create a fault here only in 1, so the fault should be only in 1. It should not be in others. So it is like a loop connection. You go panel to panel and then you go until the fault point. So this will help you to identify the feeder and also take you to the exact fault point. So you can increase the signal strength here to see whether it is faulty or not. Then let's go to the next feeder. Refresh. You can still see that there is a fault continuation happening. Okay, so the fault is still 4th. So next we go to the next feeder and then we refresh. There's no signal. So which means the fault is still this point. The fault is not going to the other point. So you are exactly knowing that where the fault ends at. So this is how you can do. Let's go to the negative feeders and check. Since there is no negative fault, there should be no signal in the negative. So just a straight line. So there is no fault in the negative. So this system is very accurate and helps you to exactly pinpoint which feeder is faulty, and it will trace you till the fault point. So let's see how our big sensor can help you. You have seen the sensor here. So always clamp and refresh so that you can see the signal, and then you press this center button once you find out the fault, once you pinpoint the fault, then this injection will stop. So it's always check that this transmitter is injecting. If the transmitter is not injecting, then you cannot find the trace of the faulty feeder. So I'll stop the signal now. Let's move with the bigger clamp. Let's connect the bigger clamp. There is a point here which helps you to exactly connect this sensor. Just press, and then this sensor, you just need to touch the cables so that you can see the healthiness of the feeders. Now let's go with the ground. Let's start injecting the signal. This is the button. Please wait. Signal started. Let's connect to the ground here and refresh. So there is, the ground is saying that there's a ground fault. Let's see whether it is positive or negative. Let's keep only on the positive. The signal strength is very high. Let's make it little low. Then again refresh. So you can see that it is showing fault on the positive since it's a positive ground. Then let's keep it on the negative. Okay, and then refresh. There's no fault, no signal. Again refresh. No fault, no signal. So this clearly states that how these sensors works in different conditions, faulty condition and healthy conditions. This is how this equipment helps you to exactly pinpoint the fault and trace the faulty feeder, and without interrupting the DC system, you can make the system stable. If you need any information, please contact us. Thank you so much. And one more thing we need to say, that whenever you switch off the system, we need to make sure that there is no signal injection in the transmitter. Okay, and then switch off. Always remove the connections first without removing ground, and always try to touch this to the ground so that there is no induction in the equipment. Thank you.